Okay, let's talk about the second part of section 11.2 parabolas. Before we talk parabolas, let's look at the circles case. Remember when we studied the circles, we have two standard forms. Okay, so one is x minus h squared plus y minus k squared is equal to r squared. This is the standard form. The center is hk, radius is r. The center is hk, radius is r. And then we study that when the hk are both 0, in other words, when the center is origin, we have x squared plus y squared is equal to r squared. Okay, so we have two standard forms. And now let's try to understand these two stuff in a different way. Assume we do not directly get the first equation. We first get the equation x squared plus y squared equal to r squared. The center is at the origin. And then we move it it means the center. We move the center. We move the center to HK. Okay, so when we move the center to HK, the equation becomes the first one. Because we only move the center, so the radius does not change. The only changed part is this part. So when you move the center to HK, x minus h, y minus k. Okay, so that's the idea. And now we try to follow the similar thing. Here is x minus x coordinate, y minus y coordinate. Back to our parabola case. Analyze parabolas with vertex at HK. So let's just use the first one. First standard position as an example. Okay, this is a directrix focus. And the equation is y squared is equal to 4ax. Okay, so this is a standard position with the vertex at origin. Now we are going to move the vertex to HK. You see here, we move the center to HK. Here we move the vertex to HK. The vertex is at origin. It plays a similar role as the center, even though it's not the center, but it plays a similar role. We move the vertex to HK, then follow this pattern. We use x minus h, y minus k. Okay, so x minus h, y minus k. So this is the equation for the new parabolas. The new parabola is possibly like this. For example, this is a HK. HK. Then you imagine that you have this visual line. This should be the y-axis, but now it moves here, and there's a x-axis like this. And okay, my bad, it's too close. The graph is like this, and this point, this A means the distance between the vertex and the focus is A. So here it's also A. You only move it, you do not stretch it. And here, the vertex to the directrix is also A, so that's why here it's negative. This is A. Okay, but you see that's a distance back to the coordinate. This point, the x position is h, to the right h plus k, plus a. H plus a. Horizontal one is a k. This is the focus, the new coordinates for the focus. Here move to the left minus a, so and put here x is h minus a. Okay, so after you move the vertex to hk, the focus becomes here h plus a k, so k. Directrix x equal to h minus a. Okay. So that's the geometry, and the axis of symmetry becomes the horizontal axis y equal to k. Y equal to k. So that's the result after you move the parabola, you move the vertex of the parabola to the hk for the first standard position. Okay, so let's study this again. When you move it to hk, focus, directrix, symmetry, they all changes. If you cannot memorize them clearly, you try to sketch it and use this pattern. Of course, if you can memorize it, it will be faster for you to do the computation. Okay? So that's it. And in this part, for those 3 units, you always plus h or plus k in the corresponding position. So you see, originally the focus is a0. Move to hk, so a plus h, 0 plus k, so hk. X directrix is a negative a plus h, so that's why you get h minus a. It's a negative a plus h. And the symmetry, the original symmetry is a y equal to 0, the x-axis. X-axis is a y equal to 0. Now it is y equal to k because 0 plus k is a y equal to k. So here is always addition, but in the equation part, it's a difference. This is always equation, but here is a difference. X minus h, y minus k. Okay, so similarly, let me write down all 4 cases. This is the first case. Second case. This. Oops. this is a negative a0 focus, x equal to a. After the vertex, this equation is y squared is negative 4ax. We move it to HK. Doesn't matter where HK is. I always put a visual coordinate. So this is a y equal to k. This is h, this is k. And the focus is here. So it's h minus a. H minus, and this place is H plus a, and okay. So here the original. Let's put the focus. Focus negative a0. Directrix x equal to a. X is symmetry. Y equal to 0. Okay, so 3 informations. And this place, let's talk about the 3 informations. The equation becomes y minus k negative 4a times x minus h. It's always subtraction for the equation. Equation part is always subtraction. Y minus k, x minus h. And the focus becomes f h minus a 0. You see, add h. Why I always put 0? Sorry. It's k. It's k. F h minus a and k. Always add. And the directrix x equal to h plus a. You see, a plus h, h plus a. Axis of symmetry, not directrix. Axis of symmetry is x is y. This is axis of symmetry. Y is equal to k. Y is equal to k. So the y plus k. So in this part is always plus. In the equation is always subtraction. It's the second case. So this is the first case, second case. And the third case, well, basically there's no number. I just label them first, the second. A. So this is x squared is equal to 4ay. And the focus is 0a. And this is x, y equal to negative a. The directrix y equal to negative a. X is a symmetry. The vertical is x equal to 0. Okay, and then we move it to a different place. This is HK, and now the vertical direction is A. Here is A, and so the distance is A. This distance is also A. Okay, so H, now it's a K plus A, so it's a H, K plus A. It's F. F is H, K plus A. That's minus A, K minus A, so the horizontal y. The directrix is y equal to k minus a. And the axis of symmetry is x equal to h. The equation becomes x minus h squared equal to 4ay minus k. Okay, so you can either from the geometry to get the new information about focus, directrix, axis of symmetry, or you can just directly add. You see, hk, here add h, here add k, here add k because it's y. Y you add k, here x add h. And the last one, we are going to list all four stuff, and I will show you how I get it. I never memorize that directly. I try to use the geometry to get it. The focus f is negative 0, negative a. The directrix is always for x. Y is equal to a. Okay, so the equation is x squared is negative 4ay, and the focus is 0, negative a. Directrix is y equal to a. Axis of symmetry is y-axis is x equal to 0. Okay, now we move it to a different place. You see, the reason I choose those position is that here, if I put this hk in this place, when I sketch it, I will get intersection. It will make the whole graph more complex. So that's why I choose the point at this place. So when I sketch it, I don't have intersections. Intersection may happen, but this way I get a clear picture. That's only for the demonstration purpose. This hk is not always in the first quadrant. It can be whatever quadrants, okay? So here is similar thing. Because I'm going to draw a opening down parabola, so I select this position so that the new graph does not intersect. Does not intersect the xy axis. I don't have even more complex graph. So this is hk. So this is k minus a. This is k plus a. Y equal to k plus a. And this is a. This is a. And the rotation axis of symmetry is x equal to h. So focus is 0, k minus a. Directrix is y equal to k plus a, and axis of symmetry is x equal to h. The equation is x minus h squared is negative 4a times y minus k. Okay, so all four cases can be written or can be cleared by this method. Our observation is an analog of the circles. Okay, so we just try to study the circles case and back to our parabolas. And later we will have a systematic study about this movement and stretch and stuff. But here, because we didn't have that argument, so we cannot get even further discussion about the transformation. Just use the movement. Okay, now let's see the examples. Example, find an equation of the parabola with vertex at -2, 3 and the focus at 0, 3. Graph it. Okay, let's check. -2, 3, 0, 3. 1, 2. This is -2. 1, 2, 3. This is up 3. So this is -2, 3. It's vertex. -2, 3. Focus 0, 3. 0, where is 0? 0 is here. 0, 3. This is the focus. Okay. So you have vertex, you have a focus. You check here. All four cases, standard forms, the opening is always towards the focus. Focus always inside. So when you have the vertex and the focus, the graph should be like this. Okay? And this is the axis of symmetry. And then check here. This is A. The distance between the vertex and the focus is A. So this is -2, 0. This is -2, 3. This is 0, 3. So the distance from -2 to 0, A is 2. A is equal to 2. Right? So here A is equal to 2. It's very important. And after you get A is equal to 2, it's open to the right. You get y squared is equal to 4ax. Y squared is equal to 4ax. This is our first standard position. Opening to the x, positive x. Opening to the negative x, -4ax. Opening to the positive y, positive 4ay. Opening to the negative y, -4ay. Okay? So this is a standard formula. Because A is 2, so it's equal to 8x. So this equation is the equation for the vertex at the origin. A is equal to 2. But now the vertex is at -2 and 3. The equation becomes y minus 3 squared, 8x minus -2. Okay, so for you in the exam, this is enough. From here, I can see how you compute it. If you want, you can write one more step, x plus 2, but it's not necessary. This is perfect answer. Okay, so I need to check the steps. How do you think about it? Okay, so we finish it, and graph is more or less like this. You just put the directrix. Remember, the directrix has the same distance. Here's 2, so directrix is also has 2 units. So -3, -4. Directrix is here. This is x equal to -4. So the whole idea is to determine A. That's an important idea. The whole idea is to figure out A. And of course, you have to know which opening you choose. When you have A, what is A? Yeah, what is A? A is the distance between the vertex and the focus. A is the distance between the vertex and the focus. When you choose figure out A and you determine the opening, you write the equation for the standard position first. You get the standard first equation and then you do the motion. You don't directly get this. This is done by the second step, by moving the standard position to the current place. Okay? So it's very important to determine A and then move it. Okay. Another example. Let me see if we find a similar example. Okay, yeah, let's see this. Assume we have we get a short thing. We find the equation for the parabola with some information. Parabola with, let's see, focus at -4, 4. Directrix at the line y equal to -2. Okay, let's try to give the equation. Y is equal to -2, -4, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is -4, 4. Y equal to -2. 1, 2. Y equal to -2. 4, 3, 2, 1, 0, -1, -2. Okay, so focus is here. Directrix is here. What is A? A is the distance between the vertex and the focus. It is a half of the distance between the focus and the directrix, because remember we always know that the vertex is a midpoint. So A is also half of the distance between the focus and the directrix. Okay, so now let's see the distance of directrix. It's vertical, so we count 4 to -2. So A is half of 4 minus -2. Difference. You're on the line, the distance is always difference of the coordinates. 4 minus -2. 4 minus -2 is a 6, 3. Okay, so midpoint is here. This is vertex. And then you will see that it's like this. The opening is to the positive y, so 4ay. Opening is a positive y, 4ay. And a the 3, so it's a 12y. X squared is 12y. And now you have to know where is a vertex. Vertex, you see there's a midpoint. The midpoint of them is on the vertical line, so the y coordinate is 4. This is 4. The point between 4 and the -2, 4 plus -2 is 2. Divided by 2 is a 1. So you see, it's exactly 1. So vertex is, okay? So first it's a 4 plus -2. This is about the midpoint. And its vertical line is a 4. So the vertex is 1 and 4. So you get the vertex, you get the standard equation for the standard position, you move it. So the required equation terms. X minus x, y minus y coordinate. Okay, so that's the answer. There's some practice in this part. I think from 19 to 36 on page 785, 19 to 36, all about this type of stuff. Do all of them if you have time. That's very important. With them, you will get the idea. The important thing is to find A, to find the vertex, if they are not directly given. A is the distance between focus and the vertex, is a half of the distance between the focus and the directrix. It is also the distance between the vertex and the directrix. You have a distance vertex directrix, this is also A. Okay? And the vertex is a midpoint between the focus and the directrix. Midpoint formula, you know that we have midpoint formula. The 1 point plus the other point divided by 2. Okay? Do the exercise. They are very helpful. Let's see another example, another type of example. So analyze the equation. Equation x squared plus 4x minus 4y equal to 0. Okay. Okay. Analyze this type of problem is always complete square process. How do we do that? First, we move this term, y term, to the right side. We will always keep the left term, x terms in the left side. Not x term, the term with a square. Here is an x square, so we leave all x term to the left side, or y term to the right side. We are going to complete the square for x. X has square, so we'll complete the square. Here's 4. 4 divided by 2 is 2. 2 squared is 4. You add 4 for the left side, you also add 4 for the right side. Complete the square, remember that it's like this. So that's why I say 4 divided by 2. 4 divided by 2, you will get A. A squared is 4. And then we put x plus 2 squared. Right side, I have 4 here. This process is determined by the coefficient of y. Whatever coefficient you have for y, you factor out. So you just factor out the coefficient of y. Okay, now you see it is an equation of the parabola. It's like a 4y. 4y means the opening is towards the positive direction of y. X squared is a 4ay. And also here we know that, we know what? We know A is equal to 1. Right? A is equal to 1 because it's a 4ay. 4ay is a 4 step 4y, so A is equal to 1. And the vertex is -2, -1. Be careful, it's x minus -2, and y minus -1. So it's always the difference in the equation, x minus h, y minus k. Okay, now let's check. -2, -1, this is a vertex open to the positive y direction. A is a 1, it means the distance between the vertex and the focus is 1. So here is a focus. This point, this distance, vertical distance is 1. The directrix is one, has one distance from the downward. So -1, this is -2. So y equal to -2. Focus is -2, 0. Move upward 1 unit. So y x does not change. Y add 1. So we get the focus -2, 0. Add 1 to it. And directrix y equal to -2. This -2 is actually -1 minus 1. This is -1 minus 1. Move down, subtract 1, subtract a. It's k minus a. This is h k plus a. And axis symmetry. Axis symmetry is this line. This line is x equal to -2. And that's it. So you have focus, directrix, axis symmetry, vertex. So you get everything. Okay. So analyze a parabola. You just mention all four, actually five quantities: A, vertex, focus, directrix, axis symmetry. 1, 2, 3, 4, 5. Yeah, and that's it. And to know that, basically you follow the geometry. A has geometric meaning. Practice exercise in this section. It's a very flexible. You rotate, you change, not rotate, no rotation. You move it, and you have opening. The opening determine the equation. The equation also determine the opening. Here is a positive y, so open upward. If you see negative y, it's all open downward. It will have opening downward. Positive x opening to the right, negative x opening to the left. Okay, so that's the discussion of a second part of section 11.2 parabolas. Do your exercise, ask me questions. We will continue in next video. Okay, thank you.